Hello, this is CST2509054 JIANQIN speaking, and I'm going to introduce the application of eigenvalue and eigenspace, PCA, principal component analysis and facial recognition. So, first part, PCA, principal component analysis. If we have a matrix A, we could do eigenvalue decomposition. A equals to PDP inverse. P is the set of all the eigenvectors, and the D is the diagonal matrix. The diagonal entries are all the eigenvalues. So if we want to stretch this matrix D, we could use the diagonal matrix S. Like this, we could use S times D to stretch this D. And if we want to do rotation to D, we could use trigonometric functions like this, R times D, and we could do rotation to D. Suppose we have a P dimensions matrix X. We want to reduce its dimensions to K. However, want to keep the most information. What should we do? This X is the original statics set we gathered from the objects. So we first of all, we need to do the original decentralization to X. From X to D, we put the center of the statics onto the original point. Then we stretch this D and do rotation and get D prime. So we could find the direction whose variance is the biggest, and this is the covariance formula, and this is a matrix of covariance. So we simplify this form into this one and separate the 1 over n minus 1 and got this form. So C equals to 1 over n minus 1 D plus D transposed. And from this operation, we could, if we want to get D from D prime, we could times R inverse and times S inverse to get this D. So D equals to R as D. D prime equals to R as D. And combine these two formula, we could get C prime equals to R S transposed R transpose S transposed. And back to the definition of eigenvalue and eigenvector, we could write these two formula and combine them to this form. And we let this vector to be a matrix R, and so we could get C prime equals to R L R inverse, and luckily we got the same form here, L and here L equals to S times S transposed, which is A square B square, and this is the L is the eigenvalue. So the variance equals to eigenvalue. So we do the eigenvalue decomposition to C. So if D has n dimensions, we want to reduce to k dimensions. We just arrange the eigenvalues by descending orders and take the first k vectors to form another matrix W, projection matrix, and then times D. Then we got the D prime whose dimension is k. So we successfully finished the operation to reduce the dimensionality of the D prime. So this comes to the part 2, facial recognition. Is a fundamental principle is PCA. Compresses the face from pixel space to eigenspace, so that only a few dozen numbers need to be compared during recognition, instead of thousands of pixels. So this is the original formula. New face equals to mean face plus this one. If we got a new face, first of all we need to subtract the mean face and project onto the eigenspace, and we got the dimension reduction k dimension coefficient vector, and compare with all k dimension vectors in the database, and finally close it, and we recognition this face. So this face could be recognized by the machine. Let's come to part 3, analytic hierarchy process. This also use eigenvalue and eigenvectors. Okay, for example, if we want to evaluate one project, we must focus on 2 aspects: evaluation criteria and corresponding weight. And its essence itself is comparison. For example, if we want to evaluate the volume of different size of cup, for example, we have 3 sizes: super big, big, and middle. And we think and we judge by ourselves, and we filled their rate. For example, if we think super big's volume is 1.5 times of the big size, we put 1.5 here. So we fill this table. After this, and we use 1 to 9 to judge their importance from ourselves. So for example, if we want to go travel, and we have 3 destinations: Suhang, Beidaihe, and Guilin. And we judge by ourselves for one criteria: scenery. If we think the scenery in Beidaihe is the worst, so we put the biggest number here. So we fill this chart, this table, and for example, the Suhang's this scenery could be 5 times better than Beidaihe's scenery. And as you can see, the diagonal entries are 1, because one thing divided by one thing must be 1. And the elements that are symmetric along the main diagonal are reciprocals of each other. And then after that, we got this matrix. We could find its eigenvalue and find its corresponding eigenvectors. Before that, we must do a consistency check to prevent the test taker from randomly inputting. If they input casually, it can't pass the consistency check. So how to carry this check? We use this formula: Ci equals to lambda max minus n divided by n minus 1. Lambda max is the biggest eigenvalue. And what is Ri? Ri equals we randomly form so many sample metrics randomly, and we randomly choose numbers from 1 to 9 and its reciprocals to form this so many sample metrics, and we calculate their their eigenvalues and find the biggest eigenvalues and calculate the average of the biggest eigenvalues. And then we got lambda max prime. So I equals to lambda max prime minus n divided by n minus 1. So CR equals to CI divided by RI. So if the value of CR equals to 0, then it is a consistent matrix. If it less than 0.1, and it passed the consistency check, so we could proceed with the process. And then after that we could find the eigenvector. Actually, eigenvector here is the weight vector. So for example, we could find the eigenvectors of the criteria 1 scenery here. And this is just one criteria, and we have so many criteria. So we do the same process to each criteria and form a big table here. So we could see the eigenvectors, 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 eigenvectors. And as for the criteria itself, we also have to evaluate. So we do the same process, and we got their weight vectors here, 1 to 1. So now we can calculate the weight. How to calculate the weight? The criteria vectors times the destinations vectors here. So for example, for Suhang, we could do this 0.263 times 0.595, and this times this times this, and we got its weight of Suhang 0.3. So we finally got 3 weights of each destination and compare themselves. So the biggest weight of the destination is Guilin's weight. So Guilin is the best destination judged by ourselves. So we choose Guilin. So that's all. Thank you. As an old saying goes, 桂林山水甲天下. So I strongly recommend you to go travel to Guilin, Guangxi Province, China. Yeah.